Good afternoon, my YouTube viewers. Crystal here. I'm just here this afternoon because I wanted to give you a code review for Kaggle's April 2022 tabular competition. I didn't score very high on the competition, and the reason why is because they used millions of rows of data, which meant that it caused the computer to crash whenever I tried to train it and fit it. And as a result of that, I had to use logistic regression, which is not always the best model to use when trying to get an accurate prediction. I had originally tried to use like extra trees classifier, which caused the computer to crash. But even though I didn't get a very good accuracy level, the reason why is because Kaggle tends to put millions of rows of data in their competitions, which is just, my computer just can't handle that. And so if you try to put it on a GPU, that's a graphic processor unit, or you try to use a different model, such as a neural network or a random forest or something like that, then there's a possibility that you can get a higher score. But I still think I have a good model nevertheless, aside from the problem with the logistic regression. So I'm going to go ahead and go over the code with you anyway, and if you can use a different model, maybe you'll get a better score than I did. So as you can see, I only scored like 0.499, and I did my best. I worked on this all day long, and so since I worked on it all day long, we'll just go ahead and I decided I'd do my best, work on it all day long, and then I'm not going to worry about it anymore because I'm under a lot of pressure to actually produce content, so I can't spend lots and lots of time on a problem, because if I spend lots and lots of time on a problem, then I'm not producing content. So I'm just going to go ahead and leave my competition the way it is. And obviously I've made this notebook public, so since I've made the notebook public, you can fork it, and after you have forked it, if you want to play around with it and get a better score than me, then certainly let me know what you've done. But this is a public notebook. So the first thing that we're going to do is we're going to look at the problem statement. So it just says, welcome to the April edition of the 2022 Tabular Playground series. This month's challenge is a time series classification problem. So you've been provided with thousands of 60-second sequences of biological sensor data recorded from several hundred participants who could have been in either of two possible activity states. Can you determine what state a participant was in from the sensor data? So that's your question, and that's all they give you to work on. You don't give anything else to work on. So the first thing that we're going to do is we're going to import our libraries of NumPy, Pandas, Matplotlib, and Seaborn. NumPy is a numerical Python library. Pandas is a library that enables you to open up data frames and manipulate them and manage them. Matplotlib is a visualization library, and Seaborn is a visualization library also that is written on the back of Matplotlib and is more precise. After we have imported our libraries, we want to retrieve our files. So we're going to import OS, which means operating systems. And what we're doing is we're actually going into the operating system to actually get the files. that we're going to be using for this exercise. And it's going to be sample submission, train labels, train, and test. And so this problem was a little bit more difficult to work on, and you will see why in just a second. So we're going to read the files. We're going to label the data frames, train, labels, test, and submission. So you look at the train file. It's 1.5 million rows by 16 columns. You're going to look at the labels, and it's the sequence. They give you the sequence, and then they give you the state. And this is another thing that's interesting. They give you the subject. So you get the sequence and the subject and the step. So, but on the labels, the only thing that you get is the sequence and the state. So, I'm just wondering really if I could improve upon my score by taking out the subject and the step and just putting in the sensor data. I'm wondering if the sensor data would improve the score. So that's something else I can do to see if I can improve the score. Take out the subject and the step, but leave the sequence in there. So we've got our labels, which is the sequence and the state. We've got the test file is 750 million rows by 16 columns. We've got the submission, which is the sequence and the state. That's what they want to see, the sequence and the state. So now that I think about this, I'm only allowed 5 submissions a day. But now that I think about this, if I take out the sequence, subject, and step and just have the sensor information, I'm wondering if that will be better. I'll probably do that as soon as I've done this code review. And then what we do is we map our labels to the train, because you only have about 26,000 labels, and you have 1.5 million rows, so that's not going to work out very well. So what we do is we map our labels to the train, and so there's the code right there to map the labels to the train, and you can see the labels are mostly 0. Now we analyze our label, and you can see that it's pretty much 50-50 between zeros and ones. Now I do a scatter plot. There's your code for your scatter plot, and look at the most beautiful scatter plot that it's come up with. And so that's something nice. You should always plot your data and see what it looks like. Now we're going to drop the state from the train, but I'm going to go back later after this code review. I'm going to drop off 2 more columns as well and see if that improves my score. So target equals train state, train equals train dot state, axis equals 1, and then train. So you can see that we still have our 1.5 million rows of data in your 16 columns. Now we're going to take the train and the test, and we're going to append the test to the train. So now we've got like 2.25 million rows of data. Now we're going to drop the sequence, but I'm going to go back and drop a step and the patient as well, and see if I can improve or step in the subject as well, see if I can improve my score if I remove those 2 columns of data. I'll do that later. Then I remove the columns that have a high correlation. So here's your code here that you can put in there to remove the columns that have a high correlation. But there were no columns that had a high correlation, so it was exactly the same. I make a heat map. So there's your heat map. And then I define my X and my Y variable. So your X is combi 0 to the length of train, and your X test is combi, the length of train to the end, and then your Y is your target. And then what I do is I split my data up into training and validation, and then I select my model. And as I said before, I used a logistic regression, and the reason why I use that is because I tried to use extra trees and my computer crashed, and so I'm just using logistic regression just to get it to work. But maybe if you try to put it on a GPU and then use a different model such as random forest or extra trees or decision tree, then maybe you can get a better score, because I just got 53.75% accuracy when I trained and fitted the data to the model, and that when I predicted on the validation set, only got 53.65% accuracy. I put it on a confusion matrix, wasn't very reliable. Then I predicted on the test set, and that was your predictions, and I got an array. And so basically, if you go back to your submissions, we'll go back all the way up to the submissions. So with your test set, you had like 750,000 rows, but with your submissions, you only had 12,218 rows. So your prediction is going to give you 750,000, but you have to take that 750,000 and then you have to move that to the 12,000, because the submission is going to be 12,000. So this is my code. You can use this code. This is code that I came up with, and you can use it. So test state equals predictions. SEQ equals a blank list, empty list. Substate equals 0. Submission state equals empty list. Tip state equals empty list. I equals 0. Because you remember that in Python, the first number is 0. And then I've done a big for loop for I in range len test minus 1. If test sequence I equals test sequence I plus 1, temp state dot append temp state I. No, temp state dot append test state I. If 1 in temp state, substate equals 1, else substate equals 0. And then you go to if, another else, temp state equals blank bracket, so it's empty. If test sequence I not in SEQ, SEQ append test sequence I. Submission state dot append substate I equals I plus 1. Submission sequence equals SEQ. Submission state equals submission state underscore state. And here's what you got. You got mostly zeros. So we prepare our submission. So submission to CSV, submission CSV index equals false. That means you don't want a second index. Submission equals pd.read CSV, submission CSV, and submission. So you can see the submission. So that's it. That's the code review. And then what you do after you've done that is you save it, and then after you saved it, you can submit it to Kaggle. But I only get 5 submissions a day on this particular one. And what I'm going to do after I have stopped this video, what I'm going to do is I'm going to go through, since this is supposed to be a time series multiplex, I'm going to draw subject and step and see if that improves my score, see what happens with that regard. So I think that concludes this code review. I'll go ahead and stop the video, because this is the second video I've made. When I was making the first video, I got a call from my boyfriend telling me he's in the hospital because he snapped his ankle. So I'm going to have to go to the hospital and get him and see how he's doing, and hopefully he didn't break his ankle. So thank you so much for my subscribers for supporting me. If you like this video, please like, subscribe, and share. And I look forward to making more code reviews for you in the future.